Okay, so streaming is set up already. We are live, as they say. All right. All right. So back to this class. Let me turn on the other mic. Yep, it's good. It would be nice if I can just wear one Bluetooth device and I can walk into a classroom, have the same mic to do the recording and the broadcast and the PA. But nope, I have several things going on here. Okay, and I have a strong suspicion that we'll also need my Android device here. So Samsung is now releasing their S10, not just the S10, but Note 10. So kind of feel sorry for people who bought the Note 9, just recently, because I mean they're actually changing that quickly. But I got a super bargain on an S7. Because nobody wants an S7 these days anymore, but for teaching a class, it's really a nice tool to have. All right, so getting back to our stuff here. Let me get rid of this window. And okay, so a quick review of what we talked about last time, which is treating components as values. So what we'll do is we'll revisit one of the sample programs that I wrote on Monday. So we go to App Inventor, go back in, and through the school account. So I wrote two programs. One program was a bunch of sprites. So this is a bunch of labels. Okay, so this is the easier one. Let me just double check, make sure the recorder is on, because otherwise that kind of defeats the whole purpose, right? Yep, recorder is on, we are streaming, so we are good. Let's see, output capture is turned off. Okay, that's good, that's fine. Okay, just want to make sure that I'm not mishandling the audio setting of the recorder. All right, so anyway, so many times, depending on your app, depending on what app you're writing, if you have a whole bunch of things that you want to turn on or turn off at the same time, or you want to change the font size at the same time, or you want to bold at the same time, you want to hide at the same time, it's really tedious to have to treat each component individually, because I mean it can be done, but it's really just a whole lot of hassle. Okay, so this particular sample program illustrates that if you have a bunch of labels like these, 4 labels here, and you want to change the font size either using an algorithm or just to a certain constant, and you don't want to do it individually, then you can do it this way. So when we look at the blocks, we have an initialization. This is the initialization part. And let me see if I can move things around. Oh, there's a really kind of cool feature. Well, it's cool and not cool at the same time. It all depends on how well you can organize your code. If you right-click here, it can do a cleanup, but it can also arrange blocks automatically by, horizontally, vertically, or by category. So if you do it by category, this is what it does. Okay, you can see how it automatically rearranges things, horizontally like this. So it's kind of nice when you have a screen that is like really, really messy and you just want to clean it up a little bit. Okay. It's kind of like hiring a housekeeper. So the good thing about a housekeeper is, the housekeeper will do the housekeeping. The bad thing is, after the housekeeper has gone through your house, you may not find your stuff anymore because it may not be put where you think it should be put. Okay, so anyway, the initialization block of the screen is doing the initialization with the global variable labels, setting it to a list of the labels. So this is the really cool part, is the label each label, even though it is a component, but you can also use it as if it is just a value and put it into a list. Okay? So, yes?
So based on how it shows up right there, like it says screen one, get set global label, or set global label. So where the initialize takes place, that's the third thing that takes place?
Yes.
Okay.
So when the screen first gets initialized, this block of code also gets executed automatically. Okay? All right. So once it's initialized, when I click the button, this is what's going to happen. So what's happening here is instead of individually going to label 1 and say, okay, go get a random font size, go to label 2, go get your own font size, and so on and so forth, I set up a loop here. This is a for each loop where it is saying for each item in the list, okay, starting from the first to the last one. So for each iteration, item is associated with one of the items inside the list, okay? And so for each iteration, I can just say, oh, okay, whatever item I'm having here, which is one of the items in the list, set the font size of that particular item, which is assumed to be a label, to a random number from 10 to 30. So that's a very handy feature, because if you have, many text fields and labels and stuff like that, and you want to initialize those from a list that you're getting from TinyDB or something like that. So instead of individually getting those and risking that you might get an index wrong and whatnot, you can use this approach and quickly, initialize a whole bunch of stuff. Okay? So this is the first program. And then the second program that we also talked about as an example to do this, let me go back to my projects. It is the font, the sprites. So the other program is called Bunch of Sprites. And we have all of these dots basically moving around. And when they collide with each other, we want to change the background color depending on whether it's the same color colliding or it's a different color colliding. And the program worked. But if you do not do, if you don't use the technique that we are talking about here, the logic gets a lot more complicated. So this time I'm going to clean it up and say arrange blocks. It doesn't give me the option of arrange blocks by category, which is kind of interesting. It does let me do it horizontally, vertically. So now we have, all the blocks, arranged vertically. And, I think we're missing some of the blocks. Yep. So that's why, it's not always working the way you think it should be working. I don't know why this one is different. It doesn't give me the option of arranging by category. Anyway, so with this one, let me go find the initialization block. This is the bad thing about graphical programming, because it's really hard to find something especially when your screen resolution is lower. If I had a higher resolution, which I do on this screen, but not on the projection screen, it would be a little bit easier for me to find my stuff here. Okay, where's my initialization block? Let's see. Collapse blocks, enable all blocks, disable. This one is different. Oh, there's more stuff. Just have to keep going. Keep going. Okay, there we go. Okay. So with this particular program, the initialization block has two lists to initialize. It initializes one list, for the green balls, and it initializes another list for the red balls, right? So you can see how the green balls is just a list of the two green ball sprites, and then the red balls as a list is just a list of the two red balls, as sprites. I'm re-explaining because I forgot to record the previous lecture, so I'm quickly going through the same thing again. Okay, so even in initialize, I'm making use of the lists So I'm making sure that each one go through the start to ball process. So this is the other nice thing of treating a component as one thing. Okay, is you can pass the component around to procedures. So in this case, the procedure, which is start ball, is here. So start ball as a procedure has one parameter, and we are making the assumption that whatever the parameter is in fact a ball component, okay? And there's no way to check it, okay? I already looked into App Inventor, and there's no such thing as, okay, is this a ball, okay? I can check again, there might be a way to do it. But anyway, I'm making the assumption that ball as a parameter is in fact a ball component. Then I can say, oh, change the heading of this ball component to some kind of random number, to specify an angle. I can do the same thing with speed, except, it is also a random number, and the interval is just 50 because you only need to specify one or the other between speed and interval. So if I set, the speed to be randomized, then the interval can be constant. So are we good so far with this explanation? Okay. So as I said a little bit earlier, if you are very careful and you say, okay, are we using in fact a ball? So the only place we can find it is over here, and see if we can find a way to confirm whether an object is a ball or not. I don't see it yet. Okay. Because all of these are already assuming that the object is a ball or ball sprite. So we can set all the properties. So anything you can normally do with a component, you can do it with this method. But I do not see a way to check whether it is in fact a ball or not. So if anything is not here, I could look into logic. I don't think it is going to be in logic. Nope. It's not there. Control. Nope, nothing like that. So there's no way to actually confirm that this particular parameter is a ball. So you just have to be kind of careful when you work on, when you use this particular feature. So do we have any questions about how we do the initialization, how we set up the ball so they go all in different random directions at some random speeds? Nope, okay. So the real value of this particular approach in this particular program is every time we have a collision, okay, let me go back here. So every time we have a collision, we just call a particular subroutine. Let's see, nope, that's bouncing off at the edge. I'm looking for the collision, there we go. So it doesn't matter which ball is having a collision, but every time we have a collision, all we do is we specify, let's use this particular ball, pass it as ball 1, and then use other to pass as ball 2. So this way, we are calling this subroutine called handle collision with the two sprites that are actually in collision. And then the handle collision can do the rest, which is checking the color of the balls. If they are the same, then we change the color, background color to, I think, yellow. And if they are different, we change the background color to blue, okay? Or the other way around, I cannot remember which one. But the idea is we don't have to specify that logic here, 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 and here. There's one place to put all that logic. And then we do have all these, we have 4 collided with handler that we have to deal with, okay? That's unavoidable. But we do, kind of specify the logic a whole lot simpler compared to without this way of turning a component into just a parameter. So are we okay now? I mean, it's a very short summary of the previous lecture. We basically shrunk the entire lecture into like 15 minutes, but I think that's the essence of it. And I think I sent you guys the sample code already. So you have the sample code in the AIA format, which means you can import it back into your own App Inventor account, and then you can look at the code, you can borrow the code, you can play around with the code. Yep.
You said you send the sample code.
Well, there are 2 ways to get to it. If you remember how to sign into Canvas, you can go to the announcement part. So it is in the announcement, but it's also sent to your student account at Los Rios. So if you check your apps.losrios.edu student account, you should see a notification at least. I think it includes the attachment. I'm not sure. Does it include the attachment? Nope. Okay. Huh? Say again? Yeah, when you receive your email as a notification, okay. So it would just point you back into Canvas. Okay, well that's fine. You use the same password to sign into to both of them anyway. All right, so that's kind of where we left off in the previous class. So what we'll do today is also a more advanced topic, but for people who feel that, well, specifying all this logic in app inventor blocks is inconvenient, especially when you have a block of code that you have found in, say, JavaScript, and you just want to say, I just want to plop this code into my program to do a particular thing. Okay, it could be the SHA, hash function, SHA2 hash function, or something that's kind of standardized and just want to incorporate that code into your program. So today's lecture is all about that. Okay, is how do you basically run JavaScript code within an App Inventor application. Okay, it opens up all like new doors to what kind of complex things you can do, especially when it comes to computational stuff, and also kind of backend stuff to talk to other servers and whatnot. So we'll get started with this one right away, and we'll start a new project. Okay. So I'll start a new project and we'll call that JavaScript 1, okay, which kind of implies that we'll have multiple of these. So when you have something like this, you will need several things. The first thing you're going to need is a web viewer. Not a web component, but you need a web viewer. And you do not need it to be visible, okay, so you can just turn it invisible. So even though it is a visible component, it is not visible anymore because I just turned it off. Now, it is not disabled, which means you can still interact with it, but you cannot see it anymore. So this seems like we are completely defeating the whole purpose of having a web viewer, because the whole idea of a web viewer as opposed to a web component is a web viewer is a mini browser. You can display HTML code, and the user can click on those links and interact with content inside the web viewer. So what is the whole idea of putting this as a component into your application, but yet turning it invisible right away? Okay, I'll explain that later. Okay, but this is not a mistake. Okay, what you need is a web viewer. So the next thing we do is we go into the help content of a web viewer, and then we'll look at several items that are particularly of interest to us in this lecture. Okay, so there are properties like these: current page title, which is not terribly important to us; current URL, important. Okay, so we'll talk about how to specify the URL. The other stuff, height is not important because it's not visible. So height, width, visible, those are not really important. Web view string, okay, this is going to be important. Okay, so we'll pay attention to this thing a little bit later on. Okay, all right. So now what we want to do is we want to write a little HTML document that includes all the usual stuff, but there's no display element. But we want to specify a JavaScript inside the HTML document. How many people know what is HTML, hypertext markup language? A little bit, okay? So what we'll do is we'll do some really simple stuff. And I'm just going to use a non-syntax highlighting editor. Oh, no, that's not what I want. Okay. Try again. Nope, mouse pad. Okay, because I don't think I have any, well, I can use VI, but mouse pad is it's gonna be fine. It's just a little text file here. Okay, so the one you're seeing is just a line number, so just, don't let it bother you. So an HTML document starts and ends with the HTML tag, And then in here we have head, which is empty. And then we have body, which is also kind of empty for the time being. So right now, I'm not interested in specifying actual content. I just want to make sure that this file is included in your app. So how do we include this in your app? So what you need to do is to save the file first. And where you save on your local computer is not really important. I'm just going to save it to a temp folder, and we'll just call that JavaScript 1, okay, with an extension of HTML. So are we doing okay so far with this process? Okay, so we save the file, okay, and oh, it actually does syntax highlighting when it knows that it is an HTML document. Cool. I didn't know that. All right. Huh? Yep. Okay. It's still a box. It's just a very oddly shaped box. It actually, if anything, it looks like a monolith. It looks like the monolith, but with wrong proportions. I really want to make sure, I want to see a computer that is made with the correct proportion as the monolith in 2001. Does anyone know what I'm talking about? No? Okay. I'll show you. Monolith 2001. Oh, okay, 2001. Come on. Keyboard, stop bouncing. Okay, so if you look at images, that's the monolith. This is the monolith with apes. And this is it's a painting based on a frame of the movie, 2001: A Space Odyssey. So this is the monolith. It's a kind of long, really long-ish, rectangular shape thing, kind of thin. So we're not gonna see. Oh, you know what device looks like a monolith now? Your phone. It's a miniaturized monolith. If you have not watched that movie, I really encourage that you at least give it a try. It's a sci-fi movie, made in I think 1967. But the special effects is actually not bad, especially considering that it is a very old movie. It's very realistic, which means certain scenes can be a little bit boring. So it's not like Star Wars, okay? Where even the transport ship makes all kinds of cool sound, right? The engine has like that, and then people on in a ship, they're always they always have gravity, right? In Star Wars. Nope, not here. Okay, they're much more realistic. There's zero gravity inside the spacecraft except for a ring where it self-rotates. Then you have the centrifugal force to emulate your gravity. But it's really great as a movie. I know I'm digressing. But it's a really great movie, especially because AI is now becoming more and more and more realistic. Okay, so when you watch this movie in '67, you go like, nah, there's no way a computer can talk to a person, right? When you watch this movie in '85, okay, you basically have the same reaction, okay? In '85, we do have computers. We have IBM PCs, right? The original IBM PCs. And you go like, nah, there's no way this computer can actually interact with me using speech. You watch this movie again in year 2001, which is the title of the movie, and you will still say, no way. There's no way a computer can talk to me like that. You watch the movie today, in 2019, you go like, that is creepy. That's exactly how Google Assistant or Siri or Alexa can talk to me. Okay? Because the technology is progressing faster and faster. So what we thought was pretty much out of the world, not possible, even in 2001, okay, is now saying like, oh, my phone can do that. I don't need a spaceship to do this. My phone can do this. Yes.
Do you think that people took what they saw in the movie and thought it was a great product to create?
That might have some influence. It might have some influence, but I think for the most part, it is not. I mean, modern day AI, is born out of basically necessity. Because it's a quicker way for people who are driving to interact with your phone. So you can say, okay, navigate, okay, Google, okay, I hope you guys don't have a Google phone because that would trip the Google Assistant to pay attention right now.
What?
And then, yeah, if you turn on Google Assistant, huh?
I still find all of it so far off.
It might be far off, but AI is getting to the point where you can ask questions in natural language, and it can answer your question in natural language too.
You notice, like in Star Trek,
Mm-hmm.
there's no AI or talking to the computer BS, and I prefer they work on that stuff. I'd rather have replicators and transporters. Screw AI.
No, it's part of what we have now, so there's no turning back.
But I'm just saying, Star Trek is way more advanced in the future, right? Like,
No, they do have the computer.
But they don't have an AI computer.
They do.
Okay. No, it's gonna be blown up by the end of Discovery. If you're watching Discovery. But
Discovery predates Enterprise D, right?
It's not the same. It's not the same.
It's an alternate universe. Okay.
It doesn't even. I don't even think it exists.
Okay, so I'm gonna do it. Okay, let me crank up the volume here. Okay, and I can hold it closer to my mic both.
If you had transporters, you wouldn't need Google Maps and ask it.
Yes, you do. You actually need a lot of traffic control to make sure people do not materialize at exactly the same point at exactly the same time.
It doesn't have to have artificial intelligence.
Or you can just buy insurance.
For your children.
Just in case, right? Multiple spaceships all materializing at the same spot at the same time. Yep. What do you think of the movie 2001? Okay, it gives me a link, but usually it actually speaks the result. Okay, let me ask you another question then. What is a good stock to buy today? Nope, just gives me a link. Okay, maybe that part is not working the way I thought it would be working. Maybe I need to go to Google Assistant first. So give me one more chance here. Google Assistant. I might have it uninstalled. Oh, right there. There we go. Google Assistant. What is a good stock to buy today? What is a good stock to buy today?
Check out these results.
Check out these results. Okay, that's all it said. But it does give me a link, like five of the best stocks to buy for April, 10 of the best stock to buy for 2019, and so on and so forth. But anyway, in the movie 2001, HAL 9000 is basically an AI program that is capable of not only natural speech interaction with an end user, but it can also think. It can deduce, it can plan, and it can execute plans. So watch that movie. It's really, really a cool movie. And since we were talking about mainframes the other day, remember? Okay, when we think of mainframes, we think of IBM. The computer in that movie is called HAL, H-A-L. So if you subtract 1 from I, you get H. If you subtract 1 from B, you get A. If you subtract 1 from M, you get L. That is the reason why the computer was called HAL 9000. Yep. And we thought mainframes would go away, right? Nope, IBM is still going really strong. And IBM now has a product called Watson. Do you guys know about Watson? Okay, I know I'm digressing even more, but I might be able to kind of tie everything together. We'll see. Okay, so this is IBM Watson, best AI for the job. Okay, and Watson, the test case of Watson was actually interesting. When they first created Watson, they tested whether Watson is effective or not by having Watson to play Jeopardy. So you might think, well, if somebody is interacting with the internet, in a game, that's pretty easy, okay? Because you have, all the knowledge in the world at your fingertip. Nope. When Watson was playing that game, it was playing the game by itself with no connectivity to the internet at all. So it had to learn everything that it thinks is relevant. It has to use natural language to understand Alex Trebek's question. It has to use natural language to answer the question in the form of a question, because that's the name of the game with Jeopardy. And it was actually doing a really good job. So watch some YouTube clips of Watson playing Jeopardy, and you'll be going like, that is creepy. Because it's self-contained, just like a computer in outer space with no connection to any other sources of information. So things are progressing, okay, faster than most people understand, because it really is going fast. So watch that movie if you have a chance. I'm pretty sure you can find it on YouTube a lot. Okay, there will be a lot of clips like that. Watson, Jeopardy, right? And they even have the full episode. From
the T.J. Watson Research Center in Yorktown Heights, New York, this is Jeopardy! The IBM Challenge. And now,
these Jeopardy champions are so smart. People say their brains are like computers. This new IBM computer is so smart. They say it's
forward a little bit.
IBM Power 750 servers. Now, when you link all of these servers together, as they have done for...
Some runner ran a race.
Ken.
What is he only had one hand?
No. Watson?
What is leg?
No. Brad?
Let's go to name the decade for 1,000.
The first modern crossword puzzle is published, and Oreo cookies are introduced. Ken?
What are the 20s?
No. Watson?
What is 1920s?
No. Ken said that. Brad?
What are the 19-teens?
Yes, the 1910s. Correct.
Final.
Right, and one last clue on the board. Let's take a look. Wanted for general evilness. Last seen at the Tower of Barad-dûr. It's a giant eye, folks. Kind of hard to miss. Watson?
What is Sauron?
Sauron is right, and that puts you into a tie for the lead with Brad.
I mean, it's just basically Googling everything, right?
Nope. As I said, it had no connection to the internet at the time.
But it has a database, right?
It has a database. It has to pre-learn everything, but it also has to understand your question. And it has to understand the question and figure out the answer and then reformat the answer as in the form of a question.
I'd be impressed the day. You see, a lot of my friends are foreign, and none of this shit works with any of them.
I have a heavy accent, but if you look at the transcription on YouTube of my classes, it's actually very accurate.
Google's actually better than Apple, to be honest. So yeah, they are. Like, I get jealous of people going, "Hey Google," and it works, and I go, "Hey Siri," and I'm like, "F you." What if it actually worked just now? Yeah, it does that sometimes, but no, it'll never work. It'll just say, "What was that?" Like,
What was that?
or it doesn't work. You have to scream at it.
All right, so getting back here, we have to somehow, get our HTML file into the app. This is how you do it. You just upload it. So you choose the file to upload, and I think it's called, what was it again? JavaScript.
I was more impressed, sorry, going back to the Watson thing, that they did something wrong. I feel like that's impressive. Because if it's in the database, it's in the database. You should access it quick, but to have it wrong answer is kind of strange. Right?
It can be misinterpreting the question because, natural language is ambiguous.
Yeah, no, I get it. But I think that's cool.
All right. So in home URL, we can specify JavaScript 1.html. I think it might need a little more than that, but we'll give it a try, okay, just to see, whether it works or not. And then we go to blocks. There's nothing to specify right now, so we get back to designer, And since I specify an empty page, so there's no easy way to check. So I'm going to make some modifications here. Okay, we'll say, Dave, I cannot do that. That's a quote from that movie. Basically, the spaceship, locked one of the astronauts out of the spaceship when we are talking about deep space on their way to the planet Jupiter. And when Dave tried to get back onto the spaceship, the computer locked him out. It's like, nope. Yeah. Huh?
I saw that.
Yeah. Yeah. Hal, open the door to the cargo bay, and then Hal said, Dave, I cannot do that. In a very calm and super creepy voice, okay? Now, if it's screaming and like, no, Dave, hell no, I'm not going to do this, you go like, okay, the computer's throwing a fit. No, it is plotting. It's trying to figure out how to get rid of the astronauts. Anyway, so one of these days, one of those Teslas may do the same thing, right? You get back to your car and go like, beep, beep. Sorry, tech, I cannot do this. And then the car just drive away by itself, leaving you stranded.
That sounds like the movie Knight Rider.
Yes, Kit 2000, right? Yep. That's reality now. You don't even need a watch to talk to your car. You have a little Bluetooth thingy that is for the most part now too visible anymore, and you just click on it and go like, name your car and then go, come pick me up.
Wow.
Yep. Some cars already are capable of self-driving. It is up to the legislature to see whether it is legal or not where you live. Yeah, but a lot of Teslas can do that already. You can just talk to it and go like, come pick me up. It will figure out your location because of your phone, and it will basically it will communicate with the car. The car can self-navigate. It can figure out what route to take to get to the closest spot where you are and then wait for you there. Yep, it's just that in most cities it is not legal yet to turn on that full self-driving mode. Yeah, you can kind of imagine the legal stuff that has to happen in order for this stuff to happen. In case a Tesla gets into a collision, whose fault is it? Is it the manufacturer's fault? Is it the owner's fault? Or is it the fault of the other party? How do you determine how much of the fault is the manufacturer's? How much of the fault is the driver's or the owner of the car? Because the driver does not have to be driving, right? I mean, that's the whole point of a self-driving car is you don't have to drive the car. So we have all kinds of new challenges when it comes to legislature because of automation. All right, so we have to turn it back into visible mode just for the time being because I need to double check to make sure that we can in fact load that page. So that's the first thing we need to do is to load the page, make sure it displays correctly. Then we can include a few scripts inside and kind of play with that. Let's see. Oh, better specify the height in a certain way because it doesn't usually default to something that's reasonable. So specify 50%, which is using only the top half of the screen, and then we'll specify 100% width, which takes up the entire width. I mean, it's just to be safe because we know that sometimes it doesn't quite do things the way it's supposed to. All right, so while this is going, we are going to start up the usual stuff that we need. So we have screen copy to project the screen of the laptop on one side, and then on the other side we have ADB already. So we are just about to do this as soon as we have the APK.
it runs slower.
Hmm?
Normally it goes faster.
Yeah, it does.
Must be a lot of people trying to make their own APKs right now.
Or, you know, the server itself is just overloaded by some other stuff that MIT is doing.
They're probably doing a backup.
Well, that's the other thing that's interesting. In the good old days, when you try to make a backup, it's pretty easy, right? Because the computer or the mainframe is not really on 24/7, 365. But these days, computers are on, 24/7, 365. And then the amount of data is also humongous. So how do you back up a database when you cannot shut down the computer first to perform the backup? You have to do a live backup. While it is backing up, the computer or the server is 100% operational. So that becomes a kind of an interesting challenge because, yeah.
Wow.
This is APK. There we go. All right, so we switch back to the screen. Unfortunately, it is sensitive to the actual resolution of my screen, but that's okay. We can always, kind of shrink it so that you guys can see it. So this is JavaScript, and it's not loading the page yet. Okay, so we need to specify the path in a slightly different way. Go back to here. Okay, app inventor file path to asset. It is not that Google does not have the answer. Sometimes you have to formulate your search in a particular way to actually get to the answer. All right. So, okay. So we know that we have to use, okay, let's look for the word asset. There we go. Okay, read from, prefix the file name with a slash, a single slash, to read from a specific file on the SD card. To read assets packaged with an application, start the file name with 2 slashes. If a file name does not start with a slash, it will be read from the application's private storage for packaged applications from blah, 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 blah for the companion. Okay, so I need 2 slashes preceding the file path. Okay, so we'll need 2 slashes here. It doesn't say anything about file colon slash slash, so it only says slash slash if I read it correctly. Let me double check. Yep, so file colon is not specified. Okay, all right, so we'll give it another try. Build again. There we go. And there's a sequel to 2001. It's 2010, which is also a movie. And if you read novels, there's a sequel after that. It is 2051, if I remember correctly. The sequel is actually pretty good. It talks about how the evil computer is not really evil. It was just misled by whoever told it, oh, this is your objective, or this is what you're supposed to do. It's a great movie to watch. It's long, 3 hours long at least. Yeah, one of these days, maybe we can watch movies in class. Nope, it's still not loading it. Darn it. Okay. I don't think we have to do anything. It should load it automatically. But just in case, okay, I'm going to include in the initialize code here. And we'll specifically ask the web viewer to, nope, all of the things it can do is already here. It should display it right away. Okay, we can ask it to go home and make sure that it is the home URL. It is the home URL. Okay. This is the HTML. This is the actual help page from App Inventor itself, because I just need to find out how to specify the path. Okay. Oh, it does use, file and then colon //. Okay. You can see right here, it says, the block sets the home URL property to either that when debug mode is true, or to this particular thing when debug mode is false. So we are definitely not debugging. We are not using we're not interactively programming it. So it would be file // Android _ asset, and then the name that we want to refer to. So the other document was actually incorrect. So file colon // and then we have, okay, let me check again. Android _ asset. Okay, so we got Android _ asset, and then another slash. Okay. Give it one more try. So as it's doing this part, we can continue to read this part here. So the key is in your JavaScript or in your HTML document, the key is you want to include your script like this, using the script tag to begin and end, and in between you can have a block of code. And then you also have onload, doing process JavaScript to basically call the subroutine that is actually doing the processing. So we'll get back to this part later, because right now we just want to make sure that we can load the page first. And it is compiling really slowly. Maybe we should watch a movie. While we're waiting, we just watch the movie. When it's done, then we pause the movie and get back. Well, since we are still waiting, and it will give me a box to let me know when the file is here, so we'll go back here and just kind of continue to read. So this file is saved as an HTML document. It doesn't have the, maybe it does. It has a doc type, but it doesn't have the HTML tag at the beginning. It only has the head and also the body. I don't think that matters. Okay, so the onload equals to is telling, what this will do is when this URL is specified in the web viewer, when this page is loaded, the first thing it's going to do is to run that particular function, which is process JavaScript. Okay, now that we got this, we'll try it first. Okay, go back to here. Nope, no. Oh, the screen kind of crapped out, probably because of the connector issue. Okay, and then we can re-upload the program. And oh, the other one is still around. Maybe I just looked at the wrong screen then. Okay, JavaScript. Yep, this one does load. Okay, so the way to specify the path is file colon ///, and then you specify Android _ asset / and then whatever file name you want to refer to. So these are the things that you are pre-packaging with the file. All right, so that is cool. Next thing we need to do is now to specify, is to look at the sample code here, and just to quickly figure out what it is doing and how we can do the same thing. So this script here is going to execute when the HTML document runs. So it will go through the initialization. It will say the result as a variable is going to be the date. It will create a new date object and then immediately turn it into a string. The second thing it's going to do is it will also initialize a local variable, or it's a variable in the script called app inventor input. And this is the really interesting part is the web viewer, which is a browser, inside your Android device has this particular method on the browser side. Okay, you cannot expect this to be around in your normal desktop browser. Okay, but on the browser that is on the Android device, it actually has this. So it is calling the subroutine, and then it's defining this subroutine here. So the subroutine that is being called on load is specified here. And it says if app inventor input.length, which is a string, if that string is non-empty, or if the array is non-empty, and string can be seen as an array, then it will write this to the document, which basically just is reflected on the document itself. So you're updating the document on the fly. And then you can also specify a result. So the result can be passed back to App Inventor using the last call here. Window.appInventor set web view string to result. So the way you get something from App Inventor to JavaScript is this one here, get web view string. Once you're done with all the computation, then you return the result using set web view string. So web view string is a bidirectional thing. Okay, when you first load the page, this is how you specify and from App Inventor to JavaScript. Okay, what is it that you want to process? When you're done with that, the other way around to return a result from JavaScript back to App Inventor is to set the same string to the result that you want to specify. So are we good so far? With this code here? Yes? Okay. Well, this is actually very different from what you normally do in programming, because we're interfacing App Inventor to a component that also has its own programming environment. Okay. So what we'll do now is we're going to go back to our sample code here. And I'm going to offset this a little bit just so they can see both at the same time. More importantly, I can see both at the same time. So now we can specify and say, okay, I have a little bit of script here. And inside the script, I'm not going to do much. All I'm going to do is to say, let's see. It has to be triggered to execute, so the onload is necessary. So we have to say onload equals to, we'll just call the function f, okay? And then we define the subroutine here. So we say function f does the following. So when we are inside function f, we can then call window.application, this is app inventor dot get view string. So we'll have my own local variable here called input, and it's going to be window dot app inventor dot get web view string. Okay, and what do we want to do with this? Well, let's just say that we want to append something to it. Okay, so all we're going to do is to say window.appInventor.set web view string, and we are just going to say, this is processed. Okay, whatever the input is processed. But we are actually not doing a single thing. And this is JavaScript, which means the semicolons are optional. You do not need to have those semicolons. So our code is considerably simpler than the other one. We are not checking the length. We are not doing anything, other than, we'll just get the web view string. We'll append is process to it. And that's all we do. Is that okay? All right. So what we do now is to save the file again. So this is the part that is kind of inconvenient, is every time you change the JavaScript that you want to execute, you have to remember to save the file first, but you also have to go to App Inventor and delete that particular asset because you cannot update it. You have to delete first, then re-upload. You can upload?
Yeah, you can upload. It'll say.
Oh, it will warn you. Okay. Okay, so that might save you a few clicks, but it will save you one click. Okay, that's good to know. All right, so we got the thing loaded back in. But now we need a way to show that, right? So we're going to have a either text box. Yeah, text box will work. So we'll use a text box here, right under, and a button to trigger the operation. There we go. So the button here is to run JavaScript. And then the text box is what we are going to set the web view string to in order to start the whole process. All right, so when we switch back to blocks, the first thing we do now is to say, okay, we are going to do something when we have a click event from the button. So we pick out this, and then we have to go to the web viewer 1, and then the first thing we do is we're going to set web view string to whatever the text box has. So this block here will do the trick. So we specify set web viewer 1 web view string to whatever the text box has. So we grab that from the text box. It's the text inside the text box, so this is the block to do it. And then we have to trigger the operation. We have to trigger the reloading of the page. So to do that, we go to web viewer 1, and it's going to be one of the methods, not going to be one of the properties. So we just go to go home. Okay. There we go. That will trigger the web viewer to refresh, quote unquote, refresh the page, and as a result, the onload method is going to be called at that time. And then we go to web viewer 1 again, and this part is we have to capture it here. So this means the execution of the JavaScript inside the web viewer is quote unquote asynchronous to the execution of the App Inventor code. They all happen at the same time. Okay, if I were to put one more block here to update the text box 1 text to web view string at this point, it may not have done it yet, because you are submitting when you click go home, it is as if you are just clicking a link on a web page. Now, how long would it take to reload the page? Who knows, right? But it will come back right away. It will just come back because it says, I have started that operation. And that's all it's going to do, is to start the operation, and it comes right back. So you do not know when it's going to be done. And that's why we have this particular event handler to basically say, oh, guess what? The web view string is now changed because of the running of the JavaScript inside whatever URI that you have gone to. Is that okay? So this is asynchronous programming, and a lot of stuff is going to look like this when you're dealing with mobile apps or web programming. Anything that you need to rely on a remote server to do is going to be asynchronous in nature, just like that. So now we can specify text box 1 set text to. So set text to, there we go, whatever the value is. So this value does reflect the new value of the web view string. So this is how we're going to capture that. Okay. So do we have any questions before I start to recompile the code to get the new APK? So we're good?
Well,
Yep, go ahead. Yep.
So as we're adding more and more code,
Mm-hmm.
does this start crowding up our phones? The object code.
Not by a whole lot. Not by a whole lot. Because the web viewer is already there, which includes all the ability to interpret JavaScript. And that part is not specific to your app because your phone automatically has web view installed already. And all this is doing is to reuse the resource that is already on your phone. So the JavaScript interpreter is already on your phone. The renderer is already on your phone, and so on and so forth. So all this is doing is really just to instantiate a new object from something that Android already has. So it's not going to use up a lot of resources. And JavaScript code is fairly compact. I mean, it doesn't use up a lot of space either. Yeah. So we'll go ahead and compile this, or create my new APK file. Okay, go to build. I'm just checking to see where the audio signal goes to. Does it go to the amplifier or not? Yeah, it doesn't look like it goes to the amplifier because this cable is not in that color. So I think this one goes, this is the actual output of the amplifier. It goes to the speakers because I want to use the speakers to play whatever the computer is playing. So it seems like that's not really one of the options. The projector can play, but it's not much louder compared to the speaker on my own computer. There we go. We've got the new app. And we actually have two windows now, because I used the wrong tab on my command line thinking that it was lost, but nope, it's still there. So we reinstall. And, well, I can use either one. There we go. Come on, fingerprint sensor, go. There we go. Okay. All right. So now we're gonna say, oh, it says is processed. Okay, so we'll go ahead and change this text here. Open the hatch. Okay, run JavaScript. Open the hatch is processed. It said to is processed twice because when we load the screen initially, it ran that script. Even though the string was empty, it ran it anyway. Is that okay? All right. So here are a few questions. Okay, to extend the operation of this program, there are a few questions here. So the first question has to do with the JavaScript code here. What if I have several JavaScript functions that I want to run? Instead of just one thing I want to specify in JavaScript, what if I have 6 different functions that I want to run in JavaScript? One for SHA-2 encryption, one for blah, 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 one for blah, 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 and so on. So any type of complex logic that I find really kind of cumbersome to express in App Inventor, I might want to do it in JavaScript just because, oh, this is so much easier to type and copy and paste code too. So if you find some code from the internet that does something that you want to do in JavaScript, hey, I want to be able to just copy and paste it. Okay, so that's the first question. What if I have multiple functions that I want to run? The second question is, Well, this only takes one single string so that's the only parameter. What if I need like 6 different things, as parameters? What do I do in that case? So there are 2 questions. So what do you think?
Pass it in as JavaScript, so like a list.
Okay. Yes. So you can use JSON encoding. So you can borrow the code that I wrote for encoding, a list into a JSON format. So in the list, then you can specify the multiple arguments. So you can specify argument 1 is the first item in the list, argument 2 is the second item in the list, and so on. So you can pass a list in the form of a JSON text. Okay. So that solves the one problem. What if I have several functions that I want to call? Yep, you can do that. So you can have multiple JavaScript files. But you can also change the string so that the first item of the list identifies which function you want to call. So now you can use a switch statement or conditional statement inside here to differentiate based on the first item of the list and go like, okay, should I call function F, or should I call function G, or should I call function H, and so on. And then the rest of that list will specify the arguments to those functions. Now, when those functions are done, they might return or reply with something that is not just a single string, but you can always turn it into a JSON. Okay, so what do you think is the complexity of converting a list into JSON format and the other way around when you're in JavaScript? It's a trick question. It's super easy, right? What is JSON? What is JSON? It's not JASON, it is JSON. JS stands for JavaScript. So if JavaScript object notation is the full name of JSON, and we are programming in JavaScript, don't you think that's to be a pretty easy thing to do? Yep. So you can get around, limitations, like that, just by passing in, a complex object or list or hierarchical list if you want to, using a single string, do all the processing, and then the result of whatever you have, if it's not already in JSON format, change it to JSON format, pass it back to App Inventor. Okay. So this is really kind of interesting and also useful depending on what you want to do. Because if you want to do any type of things that is relatively complex, even CRC checksum, okay, you don't want to do it in App Inventor. Okay, so do you guys know what is CRC checksum? Okay. I'll just kind of pop it up here. CRC checksum. CRC checksum stands for cyclic redundancy check. That's what the CRC part comes from. It is not Consumers River College. They did not invent their own checksum mechanism. Okay, but when you look at the algorithm, okay, so I'm going to scroll down to the algorithm here. It doesn't look too complex, right? I mean, pretty darn easy to do. But you do need to maintain some kind of a table. You have to look up, and you have to do exclusive OR and right shift. None of this stuff is easy to do in JavaScript because take it back. None of this is easy to do in App Inventor because App Inventor does not give you bitwise operators. So you cannot do bitwise exclusive OR. You cannot do bitwise and then the array lookup thing, is kind of difficult to do too. A list is kind of like an array, but it's not really. So all this code here is going like, that's not easy to do in App Inventor. So convert it into JavaScript. And you might say, but I don't know JavaScript enough to write CRC checksum in JavaScript. Well, that's the power of the internet at your fingertip here. Let's see here. So some people have already written it for you. Okay, this is from GitHub. But just because it's in GitHub doesn't mean that you actually have to know how to use GitHub. You can just click on source, click on crc.js, and here's the source code in JavaScript. So what you need to do is a function, and let's see, this is the code to do the computation. I'm just looking at the, It is kind of simple because this is a function definition, and it's a nameless function, and I'm just trying to figure out where it's getting the bytes that it's going to process. It's doing a CRC computation based on the modules. It's using a lot of anonymous functions, which is way beyond the scope of this class to discuss. But let's just say that you found one that is easy to plug and play into your script. Well, with this ability to include your JavaScript into a web viewer, you can now incorporate any type of JavaScript you can find on the internet. You do have to massage the parameters and the return result apart a little bit to make use of the web viewer string. But other than that, for the most part, you can just kind of use whatever function you can locate on the internet. So that can greatly amplify what kind of logic you can express in App Inventor. Because expressing that kind of logic, okay, let me just kind of switch back to what this kind of logic here. And, oh, did I click on something else? Okay, so in order to express this logic here, what you're seeing in this code here, even if you are very good at JavaScript and you understand exactly what this is, translating that into blocks in App Inventor is going to be difficult. Not impossible, okay? I know how to do exclusive OR. I know how to do bitwise AND when there's the absence of those operators, but I can emulate the effect of those things using modulus arithmetics, so for the most part, mod can do it. And then bitwise AND gets a little bit tricky because now you have to kind of cancel out bits, which can also be done by but it's not going to be easy. Okay, so the bottom line is, there are certain things that are way easier to express in JavaScript than it is in App Inventor. Do those in JavaScript. Interact with JavaScript this way. Okay, so we got, let's see, 3 minutes left. So what we'll do in the last 3 minutes is to illustrate the fact that you do not need a web viewer component to be visible to get it to do its work. So we'll click on the web viewer component, turn it invisible, keep the program exactly the same as before. Okay, so rebuild it. I mean, one thing you can possibly do with this is you can do a semi-three-dimensional thing, like objects that you can show using a canvas, but it's actually three-dimensional. But all the matrix operations to do all the translations and whatnot is done in JavaScript. So now you just get a whole bunch of points, getting those points back in App Inventor. Then you just go through the polygon thing and just redraw all those things. But the actual calculation is not done in App Inventor, it is done in JavaScript. So that's kind of one thing you can do with it. So it kind of extends what you can do with your app. So, we want to re-upload. And the screen has timed out already. Okay. There we go. The new phones don't even have like a special sensor anymore. I think on some of the new phones, the touch screen itself is the fingerprint sensor. So there's no special place for you to kind of, some phones have it on the back, some phones have it here, but the new phones, actually have it incorporated into the display area, which is kind of cool. Okay, so we're gonna, this is already proof that it is running. It ran twice already, but we're gonna do the same thing here. Open the hatch. No, go back. And then run the JavaScript. It works. So that means the web viewer component is actually in the background. It's not even visible. All I'm doing is I'm just using it to process JavaScript. So are we okay so far? Okay. So this is really kind of exciting in a way because JavaScript can easily interact with other servers on the internet, which means if you want to maintain objects in 3D objects using a server so that you can display the same thing on different people's phone, you can now do that, and then it will just be rendered using app inventor code using the canvas locally. So it won't be really fast anymore, but it will still be able to see the object being rendered locally. It's kind of cool. Except GPS is not very high precision, just because the government doesn't want us to have access to high precision GPS location. Because otherwise, you can write an app. Okay, I'm just trying to turn off my phone here. To kind of share objects in virtual 3D space and then have augmented reality, so that we can pretend that there's a sofa here, right? And then your phone, based on your angle of view and based on your angle of view, will render the couch correctly, the sofa correctly, and then from my view, it'll be rendered correctly. It'll add a whole new dimension to Easter egg hunt. Augmented reality Easter egg.